Welcome, maths adventurers. Let's solve the paradox by looking at the function the time reversed equation. Let's assume we have a question like this under function that a machine reverses time numerically. When you input a number x, it outputs a new number f of x defined recursively based on a string time reversal rule. Given f of x to be equal to x squared minus 10 f of 1 over x for x is not equal to 0 and assume f of 1 is equal to 6. Our first task here is to find a closed form expression for f of x. To recap the problem, we are given f of x equals to x squared minus 10 f of 1 all over x for x is not equal to 0 and f of 1 is equal to 6. So now let's find a closed form expression for f of x. So the first step is to use the functional equation, which is f of x to be equals to x squared minus 10f of 1 all over x. Let's call this equation 1. So the next thing is to substitute 1 all over x into equation 1, and that will give us f of 1 all over x, which is equal to 1 all over x squared minus 10 f of x. So this gives equation 2. We can now substitute equation 2 into equation 1 by dropping the entire equation 2 into equation 1. That is, anywhere you say 1 all over x, you drop the whole of this equation into 1 all over x. And it goes this way by saying f of x to be equals to x squared minus 10 open brackets f of 1 all over x, which is equal to 1 all over x squared minus 10 f of x, then close brackets. So this can be simplified as f of x to be equals to x squared minus 10 all over x squared minus times minus give us plus, and 10 times 10 give us 100 f of x. So by bringing all the terms involving f of x to one side, we have f of x, and this will come here as minus 100 f of x to be equals to x squared minus 10 all over x squared. So this is what we get by simplification. By further simplification, we can see that this minus this will give us minus 99 f of x, which is equal to x squared minus over x squared. From here, we can find the value of f of x as f of x to be equals to 1 all over minus 99 bracket x squared minus 10 all over x squared. And this will be the closed form expression for f of x. So now let's check if it agrees with f of 1 is equal to 6 according to the question. So we say f of 1, we plug 1 into this function as f of 1 equal to minus 1 all over 99 brackets 1 square minus 10 all over 1 square. So this gives f of 1 to be equals to minus 1 all over 99 brackets 1 minus 10, and that gives f of 1 to be equals to minus 1 all over 99 brackets 1 minus 10 gives minus 9, and this automatically gives minus times minus is plus, and this will give us 9 over 99, and that is 1 all over 11. So f of 1 is equal to 1 all over 11 and not equals to 6, meaning that there is a contradiction, as this could be intentional to create a paradox or a trap in the problem, because f of 1 should give us 6, but f of 1 gives us 1 all over 11. So this is a paradox. The second task is to determine all real x such that f of x is equal to f of 1 all over x. To determine all real x such that f of x is equal to f of 1 all over x, you'll recall that f of x is equal to minus 1 all over 99 bracket x squared minus 10 all over x squared. So from this, we can find f of 1 all over x. So f of 1 all over x means that we are going to impute 1 all over x in this function. So that is f of 1 all over x will now be equals to minus 1 all over 99 bracket 1 all over x squared minus 10 1 all over x squared. So we have this. So from here, we can say that this expression is the same thing as minus 1 all over 99 open bracket 1 all over x squared minus 10 x squared. So this becomes this, and we have a new function of f of 1 all over x. So from here, we can put these two together, the two functions together, as f of x is equal to minus 1 all over 99 open bracket x squared minus 10 all over x squared, comma, f of 1 all over x to be equal to minus 1 all over 99 open bracket 1 all over x squared minus 10 x squared. So from here, we can see that this can cancel out from the equation, and that makes the equation to be x squared minus 10 all over x squared, which is equal to 1 all over x squared minus 10 x squared. So we have a new equation. So for this equation, we can find the value of x by multiplying both sides by x squared to eliminate this x squared and this x squared. So to multiply both sides by x squared, that makes the equation to becomes x raised to power 4 minus 10, which is equal to 1 minus 10 x raised to power 4. So this becomes a new equation. So from here, we can connect this x raised to power 4 together as x raised to power 4 plus 10x raised to power 4, which is equal to 1. Take this to the other side, and that will be plus 10. So from here, so x raised to power 4 plus 10x raised to power 4 is 11x raised to power 4, which is equal to 1 plus 10 is 11. And from here, we can find the value of x. So we have x raised to power 4 to be equals to 11 divided by 11. Therefore, x is equal to plus or minus 1, because 11 divided by 11 is 1. So our x is equal to plus or minus 1. So for real number x, such that f of x is equal to f of 1 all over x, the value for x are plus or minus 1. 3. Discuss whether this function could be symmetric, antisymmetric, or neither. To determine whether the function is symmetric, antisymmetric, or neither. To start with this, we have to check if the function is even. So let's check with the negative x. So recall that f of x is equal to minus 1 all over 99 open bracket x squared minus 10 all over x squared. So this function We're going to see if it is symmetric, antisymmetric, or neither by checking with the negative x. So this x becomes, let x equals to negative x. So from here we have f of negative x to be equals to minus 1 all over 99 bracket negative x or square minus 10 all over negative x or square. So we have this function, close bracket. So from here we can see that this is same thing as f of negative x minus 1 all over 99 open bracket. So this becomes x squared, and this is minus 1 all over x squared. As you can see, this is vertically symmetrical. As you can see that f of x is also equal to f of negative x. So this means that the function is vertically symmetrical about the y-axis. So f of x is even because f of x is equal to f of negative x. So we can ask, is it symmetrically under inversion? The answer is not generally. Only for x is equal to plus or minus 1. Question 4. What if the machine is broken and instead returns g of x to be equal to x squared plus 10g of 1 all over x? What changes? What if the machine is broken as it returns the g of x function? What changes? This simply means that this g of 1 all over x will be substituted into this function. Let's say, so it means, let's say g of x is equal to x squared plus 10g of 1 all over x. Let's call this equation 1. So the 1 all over x, which is the g of 1 all over x, will be substituted back into this function 1. So let's say g of 1 all over x or 1 all over x is substituted back into equation 1. So we have g of 1 all over x to be equals to, so this becomes 1 all over x squared plus 10 g of, if you put 1 all over x here, this becomes g of x. So we can call this equation 2. So from this equation 2, we have to take this equation 2 and put it in equation 1. So it means we'll take the whole of equation 2 and put in the g of 1 all over x, because this is g of 1 all over x, g of 1 all over x. So we have to put everything here right into this function. So we have g of x to be equals to x squared plus 10. So take a bracket. So the whole of this function, because this is g of 1 all over x and this is g of 1 all over x. So I'm going to put everything here right into this function as 1 all over x squared plus 10g of x. Then we close the bracket. So from here, we can simplify this further as g of x to be equals to x squared plus 10 all over x squared plus 100g of x. So we have opened the bracket by simplification. So with this, we can find our g of x by connecting all the g of x right in this equation. So from here, we can say g of x minus 100g of x, which is equal to x squared plus 10 over x squared. From here, this will give us minus 99 g of x, which is equal to x squared plus 10 over x squared. So this is a simplified function, And with this, we can simplify further by finding the value for g of x. So the g of x, which is what changes when this machine is broken, it gives us minus 1 all over 99 brackets x squared plus 10 all over x squared. So this is what we get, and that is what changes if the machine is broken. I know that you have learned one or two things from the time reversed equation. Make sure you click on the notification button to get notification of all our videos. Make sure you like this video, follow and subscribe. See you in the next video. Bye.